Let's see example 1. Let's suppose there is a triangle, right angle triangle ABC, right angle at B. We are given that the length of the hypotenuse is 3k, where k is any arbitrary number greater than 0. Okay, and the length of AB is given k. And now we have to find all the trigonometric ratios. Now, how do we approach this problem? Of course, we have learned the Pythagoras theorem in previous classes. So let's start with finding the length of BC. Now, what does the Pythagoras theorem state? AB square plus BC square equals to AC square. Now, we already know the value of AC and AB. So substituting, k square plus BC square equals to 3k whole square. This implies BC square equals to 9k square minus k square. This is equals to 8k square. This implies that BC is equal to root over of 8k square. This is equals to plus minus 2 root 2k. Now obviously, since BC is the length of the triangle, it cannot be negative, so we eliminate that and we get the length of BC as 2 root 2k. Now we see that these are indefinite dimensions, but since the k can be an arbitrary number, even if we assume it to be 1 or 1000, it just makes the length bigger, the angles don't change, so the trigonometric ratios don't change. Now we know the length of all the sides in terms of a ratio of k, so we can find all the angles, all the trigonometric ratios. Like sin A will be BC by AC, that will be 2 root 2k divided by 3k. This is equals to 2 root 2 divided by 3. Similarly, cos A will be AB by AC, that is k by 3k. This is equals to 1 by 3. And tan A will be BC by AB. This is 2 root 2k divided by k. This is equal to 2 root 2. Now to find the inverses, we just take the reciprocals, because that is obviously easier than substituting the values. So we have cosec A, which is the inverse of sine. We get 3 by 2 root 2. Sec A, which is the inverse of cos, we get 3. And cot A as the inverse of tan, so we get 1 by 2 root 2. Okay, I hope you understood it. If not, you can always refer to the NCERT textbook. Now let's do another example. We're going to mainly focus on examples because there are not many properties as such here. We will move on to some more advanced stuff like identities and all, but we need to understand the basics so that we can grasp the others completely. Let's do another example. We are given the ratio of tan. We are given that tan A equals to 4 by 3. We have to find all other trigonometric ratios. Now let's construct an arbitrary triangle. Suppose again, let's take ABC. Since tan A equals 4 by 3, A cannot be 90 degree. So let's suppose A is here. I will come to the fact later that why A cannot be 90 degree. Okay. We are given tan A is 4 by 3, means suppose this is 4k and this is 3k. Solving for AC by Pythagoras theorem, we see that AC square equals to 3k whole square plus 4k whole square. This is equals to 9k square plus 16k square. This is equals to 25k square. Implies, taking root over on both sides, AC equals to plus minus 5k. Again, eliminating the possibility of the negative distance, we get AC as 5k. Now, since we know the length of all the sides, albeit in the terms of a ratio of k, we can find all the trigonometric angles. Like sine A will be 4 by 5, cos A is going to be 3 by 5, and tan A we already know. Let's go to the inverse ratios. Cosec A will be 5 by 4, sec A will be 5 by 3, and cot A will be tan A is 4 by 3, so cot A will be 3 by 4. Alright, now another example. Let's do another example. Suppose we are given the value of one trigonometric ratio and we have to find others in terms of it, something like that. Suppose we are given that tan A equals to 1 and we have to prove that 2 into sine A into cos A is equal to 1. Now, we know tan A equals to 1. So in this triangle A, B, C, BC by AB, tan A equals to BC by AB is equals to 1. So BC by AB equals to 1 implies BC equals to AB. So let's assume these both have a dimension of k. Solving for AC again by Pythagoras theorem, we see that AC square equals to k square plus k square. This is equals to 2k square, implies AC equals to plus minus root over of 2k. Now eliminating minus, we see that AC equals to root over 2k. Why I am every time telling you about the minus thing is because it is a good habit to not eliminate all possibilities whenever solving an equation, even though it's obvious. It will really help you in the future, so I think you should get into a habit of it too. Just a suggestion. Now we know tan A, we are given that we have to find for sine and cos. Now sine A becomes BC by AC, which becomes k divided by root 2k. This is equals to 1 by root 2. Cos A equals to similarly k, because AB is equal to BC and both have the length k, by root 2k. This is equals to 1 by root 2. So multiplying, we get 2 into 1 by root 2 into 1 by root 2. This is equals to 2 into half. This is equals to 1. Hence proved. Currently, we don't know the trigonometric identities or the value or the angles at which these values are such. So we think that it's a lengthy process, but eventually we'll get to learn about these things, and then it will be really easy. Let's do another example. We have got suppose a right angle triangle. Say it's P, Q, R with right angle at Q. Okay, we are given the length of the hypotenuse as 29 units. Let's just say it's 29 units, and the length of the base, in this case QR, is 21 units. Alright, we have to find the values of sine square P plus cos square P and the value of sine square p minus cos square p. Now our first order of business should be to find the length of PQ, which can be done easily by Pythagoras theorem. PQ square will be equal to 29 square minus 21 square. This is equals to, let's do some calculation. 29 into 29, 9 is 8, 9 is 18, 261, 29, 30, 60, 58. So we get 1, 6, 8, 14, 5, 1, 7, 6, 41, 641 minus 21 square, 21, 21, 21, 42, 4, 41. So we subtract, we get 200, right? I was just checking, okay, this is 841, sorry, 841 is 400, sorry, my mistake, 400. Therefore, we find that PQ equals to 20. Remember the fact that I eliminate the possibility of negative 20. Now we know the value, so we can calculate sine square cos square and we can find out the answers. Now sine square P is going to give us 21 square divided by 29 square. This is equal to 21 square we just found out is 441 and 29 square is 841. Similarly, cos square P we found out cos square P is 20 square divided by 29 square. I mean, in reality it's 21 by 29 whole square sine square P. Cos square P is 20 by 29 whole square. I'm just skipping a step and directly showing you that we are squaring the numerator and denominator separately. We find this is 400 divided by 841. Now all we have to do is sum these. So we get sine square P plus cos square P. This equals to 441 plus 400. We are getting 841. 841 by 841. Which is equals to 1. The one thing you should note that even though the lengths have units and dimensions like centimeter, meter, whatever, sine and cos, all these trigonometric ratios, they're exactly that, ratios. So they don't have any units, like all you can think of length units, centimeter, meter, etc. And now we do the subtraction. Sine square P minus cos square P, we get 441 minus 400, which is 41 divided by 841. If anywhere it's asked for simplification, we can see if it's able to be simplified or not. Otherwise, this is enough for the question, for the example at hand. Let's do a final example and then we'll move on to the next subtopic inside trigonometry. Okay? We are given a right angle triangle with A, B, C. Right angle at B. It is given that AB equals to 7 suppose units. And we are also given that AC minus BC equals to 1 units. Okay, we have to find trigonometric ratios. With angle. Okay, how do we start this? Proceed similarly in a similar fashion that we have done in some of the previous examples. We need to find out the length. So we apply Pythagoras theorem. We know that AB square plus BC square equals to AC square. Now we know the AB value of AB, but we know that AC square AC and BC are related. So let's suppose we write AC in terms of BC. So AB is 7, 7 square is 49. We get 49 plus BC square. This is equals to 1 plus BC whole square. Now expanding this, I suppose you know the expansion. A plus B whole square is A square plus B square plus 2AB. Okay? It's important that you learn this right now because they will really help you in the future. We get 1 plus BC square plus 2 into A, which is 1, and B, which is BC, plus 2BC. Now we see that BC square is on both sides of the equation, so we can safely eliminate it. Implies that 49 equals to 1 plus 2BC. Now we subtract 1 from both sides. We get 48 equals to 2BC, and so we divide now both sides by 2. We get 24 equals to BC. So we get AB as 7 units, BC as 24 units. Now AC, instead of calculating with Pythagoras theorem, we have the question as AC minus BC is 1 unit. So AC is obviously BC plus 1. We get 25. The diagram is not according to scale, so don't go by that. Now we need to find the trigonometric ratios with respect to angle A. So we get sin A. Sin A will be 24 by 25 because it is the side opposite to angle A divided by the hypotenuse. Similarly, cos A will be 7 by 25. By the same logic, it is side adjacent to angle A divided by hypotenuse. Tan A will be opposite by adjacent, so 24 by 7, and the reciprocals, cosec A will be 25 by 24, sec A will be 25 by 7, and cot A will be 7 by 24. Alright, we seem to have done with the basics that you absolutely must know to learn trigonometry. Now we will move on to some specific angles ratios, like what are the values of sin A when A is equal to, say, 0 degree, 0 degree and 90 degree are not exactly possible in a right angle triangle, but I'll try to explain how we can estimate those values. Other than that, we have explanations about 30, 60, 45, these degrees, okay? Now, there is one more thing, that we are always dealing with acute angles, but these trigonometric ratios, they also extend for obtuse angles, anything greater than 90 degree and within 360 degree. These have specific values, even some are repeated. These you will learn in the future. Currently, this much knowledge is sufficient to progress. Okay.